Hi guys, welcome to cypcut tutorial. Cypcut laser cutting software is an in-depth design for fiber laser cutting industry. It simplifies complex CNC machine operation and integrates CAD, nest, and CAM modules in one, from drawing, nesting to workpiece cutting. All can be finished by a few clicks. Now let's get started. Entering the software interface, we've got Machine Control Panel on the right, Drawing Technique modules at the top and on the left. At the top left is Quick Access Bar, which is used to create, open, and save files. Also undo and redo the instruction. You can find these functions in the file below here as well. The menu bar here includes File menu and other 5 tool menus. They are Home, Draw, Nest, CNC, and View. On the left side is Drawing toolbar, which we can use to draw simple graphics and commonly used parts. We can draw lines, polylines, circles, rectangles, and we also have standard parts. And we can insert text here. If it's too small, we can make it bigger. And down below, we have trim, extend, and if we have two circles like this, we select them and click the center align. They will be center aligned. When we explode a graphic, it will be turned into several lines. And we also have the fillet. Select the graphic and click the fillet. We will get round corners. And while the first 5 functions of this toolbar are selection, node editing, sequence editing, dragging, and zooming. Node editing is used for fine-tuning graphics. Select a graphic and click the icon. For example, let's firstly draw some irregular graphic. Select the graphic, click the icon. We can see the nodes of the graphic. Drag the node to adjust the graphic. And we can edit cutting sequence manually. If unsatisfied with the default ones, it would be changed following the sequence we click. As for the last 2, drag to translate the view or zoom in it as we want. In this View module, click Select to get the drop-down menu. We use Batch Modify to modify the graphics of the same size and layer. First, select a graphic. Then we click the icon, and we can give instructions in this interface. For example, we set a lead. Click OK, and we will get 4 leads for each one of the 4 graphics. There we also have Disable Fast Drag Copy. This is for avoiding misoperation on an input file. Now we cannot drag the graphic. Also, we can choose graphics by layers or by types. And we've got 2 ways of frame. Press and hold from left to right. Will appear a blue box. Under this condition, only if a whole part was framed in the box will it be selected. And if hold from right to left, there will be a green box. As long as part of the graphic was framed in the box, the whole will be selected. And in the drop-down menu of Display, we have Display Open Figure in red. Let's draw an open figure. And we choose this. It will turn red. And we can quickly find it and to modify it. And we also have Display Microjoint tag. This is for when there are too many microjoints and we may not remember. We click the function, we can quickly find all the microjoints. And let's draw something new. Select the graphic and click the scale to modify size. Now, as we can see, the ratio is locked. We need to get it unlocked first. Say we want a rectangle of 50 times 70. Input dimension here and we will get a new one. Quick modify the graphic size can be realized as well. 2 times bigger, half times smaller. And we can find ways in transform to translate, align, flip or rotate the graphic. If we have graphics like this, we firstly select them and make it left align. Flip vertical, or we can rotate it. And when we laser cut parts, we make the cutting path start from several millimeters away from the part. This way it could get cut much better. The distance is what we call the lead. When we set a lead, first we select the graphic. Then click the lead to set the parameters. 3 lead types to be chosen: line, arc, line plus arc. And here we can set the length and angle. If we need a small hole to remove slack when we are cutting stainless steel, check this box. As for lead position, we can choose to introduce from part tip or long edge. It's just according to our needs. Generally, we recommend an angle of 0 degree for lead from part tip, but an angle of 90 for that from long edge to get a best performance. When we need to change lead type but remain the original position, check this box. And if we don't want a lead, just clear lead to delete it. And we've also got a bunch of other functions here on the right. The technique setting. First, we have start point. When we feel like changing the start point that automatically generated, just click the icon. Then a small square will appear as the cursor moves on to the graphic. And we can change the position to whatever we want. As for laser cutting, there exists a curve width. We can use the compensation. And if it's a graphic like ring, we check inner shrink and outer expand to make up for it. In this case, we can get parts cut more precisely and get the size we want. Now we get the compensation. When we cut co-edge graphics like this, inner and outer contour may get wrongly identified, say when we add leads. As we can see, the leads are invalid, so let's identify inner or outer contour. Now this is a normal part. Sometimes when we cut a long ribbon of sheet metal, it may get lifted during the cutting and hence get in the way of cutting head. Therefore, we need to add micro joints to avoid this situation. Here we have micro joint. We've got manual and automatic micro joints 2 ways. Click the icon and add joints to where we want, or choose the automatically generate the micro joints. Press Shift on the keyboard and click the micro joints, we can clear them if we don't want it. And besides, as the default cutting path goes clockwise, it goes clockwise. When we come to the bottom line of the second oblong, the sheet will vibrate for lack of support. To solve the problem, we use the feature reverse. We use the reverse to change the direction of the cutting path. So now, as sheet get a better support, it will stay steady while being cut. Down below, this is the gap feature here. In the drop-down menu, we can see the gap. Select the graphic and click it when we need to set a gap at the end of cutting path. Here is the gap. On the control rail, we can seal the gap if we don't want it no more. There are also overcut and multi-cut. Overcut is for making sure the whole part was machined, and multi-cut is for an obvious marking. Sometimes we need to cut graphics with sharp angle. To ensure a good performance, we use the feature ring cut. As always, we click to set parameters accordingly. Now we get the ring cut. And when it occurs to parts with corner to be bent in the next step, like a standard part like this, we can set relief angle here. Manually. And this fillet features different from the one at the bottom left. We can add fillet one by one according to needs. When we cut thick plate, at a corner of a graphic or the lead in, from the tip we need to get laser off to stop cutting and blow to cool the point in case the part get melted. So we can use the cooling point feature. We've got two ways of automatically cooling point and manual ones. Choose auto cooling point. We'll get every corner and the lead in position a cooling point. And if we click this clear cooling point, all but the one at the lead in can be cleared. This one, it needs to be cleared manually. So we click the icon again, press Shift and click to clear the point. And at the end, let's focus on the reference point. As we can see, on the machine panel, the red cross represents the position of cutting head at the moment. The white cross is the mouse, and this one is the reference position. The reference point means position of part 0 in relation to that of a whole graphic. When we set the reference point at the bottom left, the graphics will show at the top right of the point, as we can see here. And in the floating coordinate mode, the cutting head and the part 0 position is at the same place. So the machine process starts at the top right. If we set the reference point at the bottom right, the machine process starts at the top left of the point. There we've got exclude unprocessed layer. For example, there we have two graphics. And we now set the rectangle as not processed. And we check this box. The reference point will be at the bottom of the circle. It means it will start cutting from this circle instead of the rectangle. And though we can manually set the reference point, relative zero reference is the common choice. The floating coordinate work with zero reference can realize a flexible production. So that's for today. We've learned the features in view, geometry, and the technique setting modules, and we know how to draw simple graphics. Remember to practice. See you next time. Hey guys, welcome back to our cypcut tutorial. Last time we've learned about how to draw simple graphics, set cutting techniques, and functions in the view and geometry. Today we will learn the ways of sorting sequence for different graphics and the tools that help to get a better cutting performance. Without further ado, let's get started. Now see the sort module. We've got all these 11 ways of sorting. We've got grid pattern, local shortest path, cutting die pattern, smaller figure prior, radiating outward, left to right, right to left, and top to bottom, bottom to top, as well as clockwise circular pattern and counterclockwise circular pattern. In general, we choose grid pattern. Left, right, top, bottom. These four types are mainly used for cutting well-arranged graphics. For instance, the square matrix, select them, choose the left to right. And we can drag this progress bar to simulate the cutting path. For this we can get parts cut within rather regular and short travel path. However, there would be too many unnecessary travel paths. When we cut this kind of graphics, as we can tell, if we use these 4 modes for annulus, this is inefficient. But radiating outward, clockwise and counterclockwise are just perfect for annulus patterns. This way can we skip over unnecessary travel paths and hence improve efficiency. And here we've got 3 other options to be chosen as needed. These 4 icons above are used to manually change the sequence, like set a first to get processed or the last. These are for the sort module. Cypcut supports simple nest function as well. We've got nest here besides the sort module. First of all, we open a file that needs to be nested. Select the parts. Right-click to add them to part list. Input number. Key in number, say 50. And the parts will be in the list. Select the parts and we choose the nest. And set up the parameters and then OK. We will get the nesting result. But please note that for this nest function in cypcut, it's just at a basic level, so it supports only 50 kinds of parts and the results of 20 plates at most. So if you are searching for powerful and professional nesting software, check this website below. FriendS has prepared CypNest for you. Array here, as its name implies, we use it to generate the same graphics. Let's draw a simple rectangle, for example. We click Array. Set the size. And layout and row direction, and we can get the original graphic arrayed. The second one is dynamic array. Also, we first draw a simple graphic and choose the dynamic array. Set the row and column distances, and we hold the left button on the mouse and drag to the direction, the start point direction, as well as where to stop, at our disposal. The next is the circular array. As always, we set the parameters. And we've got ways of circular arraying like angle, degree, etc. And then we get a new graphic. The last is the full view. It means you set the size of the plate yourself and fill it with the graphic you draw. So this is how we use array. Now let's get to the group function. We draw another 2 rectangles now. Get them selected and grouped. The outcome tool will get thicker, which means they've become a part with fixed cutting sequence and their position relative to each other will stay unchanged. On the contrary, it can be degrouped into 2 original graphics. And to group a grouped graphic also can be realized. And that will demand degroup twice accordingly. First, we get them grouped and get all the graphics grouped. Now they are grouped. Sometimes we need to cut lines of small circles. Let's draw some graphics first. Now this is the normal cutting path. But on the right of the group, we have this fly cut feature, which enables us, instead of repeating the process of starting and finishing, which comes with a lot of speed changes when processing small circles, to maintain the same speed in the whole process. First, we select all the graphics. And click Fly Cut. Make sure the distance valid, and we get fly cut paths. Now this is more efficient. The same applies to rectangles. Get them selected and fly cut. The fly cut feature can be cancelled by dgroup if we change the plan. It can be degrouped. And what is co-age? We combine to generate a shared age between parts with an overlap age, so that to eliminate unnecessary cutting path. cypcut supports co-age for rectangles without rounded corner. After we select the graphic and click the icon, there will be 5 ways of co-aging to be chosen. Let's take S-button for example. We recommend overcut as default setting. Then here we got a more efficient, effective solution. And when we want co-age parts with inner contour, let's draw a new graphics. If a rectangle with a circle inside, we need to get the graphic grouped first, and then do the array and co-age. To finally generate the optimized cutting paths. This is how we use co-age. Like we've mentioned that the nest just provided in the basic level in cypcut, so is the co-age. If you would like more choices, check our website below. Our software application cypnest is rather professional. When we cut a part formed with several pieces and with closed loop, typically the number and the letters, we may need to bridge it. For instance, if we got the number 0, and the letter D, if we don't get it bridged, both of the round and the ring would fall down, and only leaves a single hole on the metal sheet, which wouldn't be satisfying. To fix that problem, first we select the graphic, switch it into curves, and click bridge. Hold left button to draw a line across 2 cutting paths. Here remember to make sure the distance between the 2 lines be within the effective distance, or you may fail to get one. Now we get our bridge line, and we can click the measure to manually measure the exact distance between lines, like this. And the figure will appear down below in the drawing bar. So this is how the bridge line works. Now let's come to the last feature. If we don't want parts get automatically optimized when input, click Manually Optimize. In the drop-down menu, we have this break grid, which is used to cut up the inner waste so that to avoid it going up and getting in the way of the cutting head. Now let's draw a new graphic. Now we use this brick grid, and normally we use grid mode and set one line for meridian and latitude respectively. And then we have the grid line. So guys, so much for today. We've learned the ways of sorting, how to use array and group graphics, optimize the cutting path with fly cut and co-edge, measure and bridge, as well as optimize graphics. Try doing some practice. See you next time. Hello guys, nice to have you back. Here is Frenda's cypcut tutorial. So far we've learned about features in view, geometry, technique setting, which enable us quickly draw graphics and set basic techniques. This sort, group, fly cut, and co-edge help us to simplify cutting path to be efficient. Today we're gonna learn a few more features of layers, task, and fine edge, as well as how to use machine control panel. Let's start with the machine control panel. First of all, we need to figure out the difference between floating coordinate and workpiece coordinate. Machine coordinate is a fixed system. To facilitate flexible cutting tasks, cypcut applies floating coordinate and workpiece coordinate. Direction definition in different coordinate system is the same. The only difference is 0-point position. The white box is machine bed, and the red cross is laser head. On the floating coordinate, laser starts cutting from where it stands. 0-point is current position of laser head. Take this position. We can start right from the point. And if we move to another position, it will start right from it. Floating coordinate usually used in small batch cutting task. Under workpiece coordinate, we've got a default 0-point with its position 0, 0. But 0-point is a user-defined position under workpiece coordinate. Cypcut allows user set 9 workpiece coordinates of different 0-point. During the process, if the cutting head was moved to other position, so long as it gets an instruction to start, it will return to the graphic that next to the defined 0-point, and then start cutting. This coordinate used in mass production scenario that a large quantity plates of same size placed in same position on machine bed which also requires a 0 point of fixed position. Down below, with these buttons, we can jog along the X, Y, Z axis. We can change jog speed, and set a fixed jog distance. Jog cut used to cut off plates. When selected, the cutting head will start to follow. Blow while jogging. And here, we can set the jogging parameter. Beside, this is burst power. Sometimes, according to need, we move the cutting head to a certain position. This mark was to mark the position with a little flag. And even if the head was moved away, by one click on Go Marker, we can go back to the position. We support 6 marks at most at the same time. Under floating coordinate, sometimes we may lose 0 point position because of misoperation. Like we stop processing, move the head and directly start again. When that happens, in the drop-down menu of Marker, select Marked 0 and then Go Marker, and we can return to the 0 point of the last processing. The program will always keep the former 0 point. And we've got Shutter. Select it to enable laser. Aiming, which is the guide laser, and click Laser to cut. Hit Follow. The cutting head will follow to the plate. In the machine control panel, we've got Start, which means to start to process. And we can also pause, resume and stop during the process. And here, fast resume is to resume without piercing. Or we can go back or forward to adjust the resume position. Set the move distance right down here when we stop processing without finishing it, and accidentally move away the cutting head. Click Position Locate. This button, we can get back to the breakpoint. Click Position Continue will directly resume from the breakpoint. We also support manually locate the breakpoint and resume from it. After the processing is stopped, return to the 0 point. Make sure this step goes first or you will lose the 0 point position. And we can right-click on the graphic, and we will find Locate here and Start from here. Just do as we want. Generally, we frame before processing to check border of cutting area. Click on Control Panel. Laser head will frame, that is dry run, the cutting zone on machine bed in accordance with drawing to be cut. We can check the cutting path by this simulation. We can change simulation speed above in the menu bar. It only demonstrates sequence in drawing, doesn't execute any motion commands in machine. Dry run is to travel along the designed tool path, not cutting it. Click Dry Run on Control Panel. Laser head will move along the tool path at preset cutting speed, while gas, laser, and PLC process are disabled. Loop is for setting up the cycle times and interval between each cutting task. As for this return 0, once we frame under the floating coordinate, the 0 point will be fixed. If we moved the laser head away, we get back to this position by return 0. Besides, we can go to 0 point and the like after process ends, or process selected graphics only. We recommend selecting the soft limit protection so as to ensure that the laser head move within the machine bed and avoid it getting crashed, and thus there would be risk if cancelled. Be careful. And here we have find edge before process. Find edge is to locate workpiece edge precisely and find the workpiece 0. We can find it on the menu bar in CNC module as well. When the plate is not uprightly lying on the machine bed, machine can find the plate angle by targeting 3 or more points on plate edge, then offset the cutting area with this angle. Click Find Edge to set the parameter. We input the real plate size and the plate margin we want, and choose where to start. We can either start from current position or from a preset start point. Click the button to start from the current position to find edge right way. For a preset point, we need to move cutting head to the position first, then click to save the position as start point. And now, even if we move the head to other position, hit Find Edge button, it will start from the preset point. Also, after the setup, on the other hand, select this Find Edge before process. The laser head will find edge before processing if we don't need to do it instantly. But no matter what, do make sure there is plate right below for the head to follow, or the head may get damaged. When we cut sheet metal, we recommend a 6-point find edge with higher accuracy. Now, apart from those, we have 2 more features to go. First, let's see the task. When we have an urgent order and need to insert a cutting task, place the plate in vacant position on machine bed. Don't move the original one. We stop processing. In the drop-down menu, we save a task file. Together with the drawing, breakpoint, find edge result of plate and the program 0. Then we open the urgent one and get it processed. Now as we can tell, the cutting head has been moved to other position. After we finished this one, load in the task file we just saved and click Position Locate, and the cutting head will go back to where it just stopped, and the process can be continued. The other is DXF layer mapping. In the drop-down menu of Layer, there is a DXF layer mapping. We already had graphics in different layers for cutting or marking when they were generated in the CAD. As it is imported into cypcut, we can appoint DXF layers into cypcut layers of cutting, marking, or layers that require different cutting techniques. Say we have this DXF format file with 3 layers. Appoint DXF layer to a cypcut layer. Click OK, apply to layers. This is how we do. On the right here, we've got this layer bar with 18 buttons. The parts geometry marked by the second one will not be cut, while the first one used to reset the parts to get cut. There are 16 layer options with 14 color buttons and the last 2 special options. With these layer buttons, parts geometry appointed by the last but one will be processed first. It also works as marking layer. Parts marked by the last button will be processed at last. Alright, these are for our cypcut laser cutting software tutorial. In the tutorial, we learned about main features of software, including view module, geometry module, technique setting, sorting, every single one in tool module, layer mapping, task, as well as the whole control panel features. All of them are utilized very often. Do improve your level of proficiency on them. And if you have any questions, don't hesitate to contact us. We will be glad to help you. Thank you for choosing Friendes. See you next time.